Hey, what's up, everybody? Welcome back to another episode of Hacking Smart Contracts for Fun and Profit. Today, we're going to be looking at challenge number 11, Backdoor from Damn Vulnerable Defi. So, to incentivize the creation of more secure wallets in their team, someone has deployed a registry of Gnosis safe wallets. When someone in the team deploys and registers a wallet, they will earn 10 DVT tokens. To make sure everything is safe and sound, the registry tightly integrates with the legitimate Gnosis Safe Proxy factory and has some additional safety checks. Currently, there are 4 people registered as beneficiaries: Alice, Bob, Charlie, and David. The registry has 40 DVT tokens in balance to be distributed among them. Your goal is to take all funds from the registry in a single transaction. Okay, well, let's check it out. So, we have our wallet registry contract here. We look at the top, we're just importing some Open Zeppelin stuff, and then we have some Gnosis contracts, Gnosis Safe, and this iProxy creation callback. We can read, there's a little notice here. It says, a registry from Gnosis Safe Wallets. When known beneficiaries deploy and register their wallets, the registry sends some damn valuable tokens to the wallet. The registry has embedded verifications to ensure only legitimate Gnosis safe wallets are stored. Okay, cool. So if we get into the contract, we can see it's inheriting this proxy creation callback and it's ownable. And then we have some variables up here, just max owner, max threshold, and we have token payment hard-coded to 10 Ether. Then we also have the reference to the master copy, the wallet factory, and an instance of the IERC20, and it's called token. Next, we have a mapping here called beneficiaries. It just takes an address and maps it to a bool. So it's just checking if the address is a beneficiary. That'll be either true or false. And also there is another mapping here called wallets, and it just maps an address to an address. Okay, so in our constructor here, we're just taking these arguments from above, and we have an array here. It's just called initial beneficiaries, so it's just taking these those people we were talking about, Alice, Bob, etc., and we're gonna hard code them into the initial beneficiaries. Then we will require the master copy address is not equal to address 0, and this wallet factory is not equal to address 0. These are just kind of standard checks. Next, we are just initializing the master copy, the wallet factory, and the token. And then finally, we are going to loop through the initial beneficiaries, and then we're going to add them to this mapping, so it will make it true. Okay. Next, we have a function called add beneficiaries. It's just a helper function here. It allows us to add people into the mapping, and then we can also remove beneficiaries here. Okay, so next we have this function called proxy created, and there's a little notice up here. It says function executed when user creates a Gnosis safe wallet via Gnosis safe proxy factory using this function create proxy with callback, setting the registry's address as the callback. Okay, cool. So it's taking the Gnosis safe proxy, the singleton which is the reference back to the master copy, and it's also taking some initializer data, and finally we have just a uint here. It's kind of just open, and we go and we see there's a check here. We make sure we have enough tokens to pay the beneficiaries, and then we let's see, this wallet address is equal to the payable, so it's just making the proxy payable so we can send ETH into it. We ensure the correct factory and master copy, so we're just making sure these addresses are linked properly. We ensure the initial call data was a call to the safe wallet. Otherwise, we're going to get this error here, wrong initialization. Next, we're ensuring the wallet initialization is the expected. So it's checking this hard-coded. So we can't change this max threshold or the max owners. This is hard-coded when we launch the contract. And then we ensure the owner is a registered beneficiary. Cool. Then we require the beneficiary's wallet owner. We're just checking here. We're making sure owner is the owner a registered beneficiary. Okay. If it is, cool. Then we will remove them from the beneficiaries so they can't claim multiple times here. So this removes them from a beneficiary, because once they set it up, they'll no longer be able to be a beneficiary. Makes sense. And then we register the wallet under the owner's name. Cool. And then we pay tokens to the newly created wallet. Okay. So that is pretty straightforward. We're basically just, when people set up their wallet, we're just making sure they're legit. And then if they're legit, we send them some tokens. Cool. Okay, so what is going on here? What is the issue? Well, luckily, there is an amazing write-up by the Open Zeppelin guys here that kind of addresses this issue here. Backdooring Gnosis safe multi-sig wallet. So I didn't really know too much about this until I kind of read up on it, but I highly recommend you go and just Google this, check out this article here. It's really good, and it really kind of explains how these wallets can be kind of dangerous, and they can kind of be made to behave in unexpected ways, and backdoored, so to speak. So I'm not going to read through this whole thing, but I highly recommend just Google this, take a look through it. I'm going to kind of just skim it and, pick out some of the more important things here. So I'm just going to kind of skim down here to the problem. So I'll just skim through this a little bit. So it says the Gnosis Safe Multi-Sig wallet can be deployed either as a standalone or preferably as a cheaper proxy contract. Okay, so basically what happens here is if you deploy this as a proxy, the Gnosis provides a proxy factory contract that can be used to easily deploy proxy contracts in front of the Gnosis multi-sig implementation. Here's a nice little diagram right here, a little stick man, and this is your proxy, Okay. So the entire system is designed with flexibility and extensibility as two of its highest priorities. Whoever is triggering the deployment is expected to call the wallet's external setup function to set, among other parameters, its owners and threshold. Okay, and this is kind of the setup that the proxy is going to be looking for. So, remarkably, further initialization data can be provided as well. Okay, using the to and data parameters. If these are provided, the wallet will use the data to execute a delegate call to whatever address is passed. Ooh. Okay, so that can be dangerous. You can find the actual delegate call, blah, 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 in here. The dangers of using delegate call to arbitrary addresses with arbitrary data are enormous, to say the least. Yet Gnosis uses a sensitive feature of the EVM to achieve the wallet's design purpose. The deployers can use the delegate call in the setup stage to execute actions on behalf of the wallet before the initial configuration is over. Example, to approve tokens. Ooh, okay. So that is basically exactly what we're going to do. And here we kind of have another diagram. It's also talking about here, complex extensions to the wallet can also be achieved leveraging the delegate call. So Gnosis wallets, they have a feature where you can attach modules onto the wallet. And that sounds cool. You can do a lot of cool things with that, but there can also be unintended activity, I guess you can say, with that. But basically, this is the whole thing right here. This is kind of, the gist of it. You can basically you can deploy a proxy that a proxy to a user wallet, and then in that setup of the new proxy, there's a delegate call, and that delegate call can call out to just any external arbitrary wallet and then pass in arbitrary data into it, which is exactly what we're going to do. And this is what we're going to do here. We're going to delegate call an attack contract, and we're going to let the attack contract approve tokens. So the attack contract will be approved to spend tokens on behalf of the proxy contract, which is going to be very bad. So that's going to be the whole setup. Basically, we'll initialize a new proxy. I guess I'll step through it one more time. So we'll initialize a new proxy. We'll do this setup. It's looking for up here. We'll create this setup, and then we can pass in just arbitrary data into this setup, and we can also pass it, like right here, it's saying like the contract address for the delegate call. So that's any arbitrary address, right? So we'll tell it to call our attack contract. That attack contract is going to trigger an approve function on the proxy, and then we'll be allowed to spend the tokens. Ooh. Okay, let's get into it. This is some more advanced stuff, but it's really cool. We're getting into some more complex attack vectors, and let's just get into it. So I'll go into my backdoor attack contract. So I just copied some stuff here just to get us going. These are some of the, this is just IRC20. This is going to be the token, and then these are the contracts from the Gnosis safe contracts that we're going to be using. These are basically all the proxy contracts that we'll be interfacing with to enable this this attack. So just the Gnosis safe, the proxy, the creation callback, the Gnosis safe proxy factory, and the Gnosis safe proxy. Okay, and I guess there's just one more. So I recommend you go through all of these. You go to the Gnosis GitHub, and all these proxy contracts are here. You can get really in depth with it and just kind of read through all the contracts. But the one we're going to be focusing on here is called create proxy with callback, right? So this is going to be the one we can do, here. Let's listen to the def here. Allows to create new proxy contract, execute a message call to the new proxy, and call a specified callback within one transaction. Cool. And it just tells us all these parameters here. It's going to take a singleton, this initializer. This is going to be the payload for the message, and the salt nonch. I never know how to say this word. Is it non? I call it like nonch, but maybe I'm not saying it right. I never really hear people say that word, so I don't know. I might say it wrong, but I digress. So this is it's gonna give the salt nonch, and then a callback here, which we're gonna make it to the original registry. Okay, so let's just start coding. So we will just need to, we don't need any interfaces here because I'm importing all this stuff. Call this contract, backdoor attack. Okay, and we'll just need to set up a couple variables. We need an address. So we'll need to make some of this stuff immutable because I was running into gas issues. It was giving me gas errors. So if you make it immutable, we can kind of get around some of those errors. So the first thing, we'll need a singleton, a reference. How do I singleton? Get my spelling right. So we'll need that singleton. We'll need the ERC20, and we'll just call this token. We will also need the Gnosis, this factory. Call this factory. And also the last thing we will need is a reference to the registry. We'll just call this registry. Okay, that's it for that. So we'll set up our constructor. Singleton. Address. We'll get this token. Oops. A semicolon. I need a comma here. The factory. And also the registry. Okay. That's it for that. And then we will initialize these inputs. We'll call them, so singleton equal to singleton. The token is going to be equal to I20, this token. So I guess I should mention too, like normally I do, if you see my other videos, I do this a little differently, but because I've used this immutability, I can't pass it in the same way as I do previously. So I have to do the address and then I kind of do it like this. Because Solidity doesn't like it when I do it the other way. Okay, so next factory is equal to, is going to be the Gnosis, say factory, and then just the registry to the iProxy callback. Okay, cool. So we've initialized our inputs. So that's it for the constructor. So first thing we want to do is we want to create, we need a approve function for the delegate call. Okay. Because we're going to be calling back into this function, or into this contract, so we're going to need to make a function to call. So basically, we're just going to say, this is just going to be approve. We will pass it an address. And we will call this address just user, sure. And then how much we want to approve it for. Oops. Let's call this amount. Okay. Cool. And then we'll just say token.approve user and amount. Oh, I need to give this a visibility. Give it external. Okay, so this will be the function we will delegate call. Okay, next we'll just set up our attack. So I'll just call this attack. We will need to take in an array of addresses. I'll just call this users. And then we also need to take in an amount, which will be the 10 ether. We'll just call this amount. This will be external. Okay, cool. So the first thing we're going to want to do, we're going to, what do we want to do first? I guess what we could do, we need to make, we need to create an array for the wallets. So I'm just going to step through like I always like to do. I kind of just put out the steps and then it helps me kind of walk through the whole process. So create an array for the wallets. We will need to create a payload and an approved payload to pass into our setup. Create an approved payload. Then we will need to create the setup for initializer. I don't know if I spelled that right. We'll create a setup for the initializer. Then we will create a proxy. Create a proxy, and when you create the proxy, it will do the delegate call back to this contract. So create proxy and trigger delegate call. And then at that point, the attack contract will be approved to spend the tokens from the proxy. So we will just transfer tokens from proxy. Okay, so that is our steps. Okay, let's just walk through it. So for this, I will use a loop because we'll want to do this for each address, right? So we'll need to kind of loop through this attack multiple times. So we'll use a for loop. Let's call it I is less than the users dot length I plus plus. Okay. So here we'll create an address array. We'll store it in memory. We'll call this wallets equal to new address array, and this will be length of 1. Okay, because we just want to store one address in the array each time, and then, yeah, we'll loop through the attack. So we'll say wallets. Wallets. The wallet's 0. So the first address in the wallets array is going to be equal to I. It's going to be, sorry. Users I. Okay. So that is good for that. So that will give us an array. Next, we need to create a payload for this approve function. bytes stored in memory. Call this approve payload equal to abi.encode with signature. And the signature is just going to be approve. And it's going to take an address and a uint. A uint 256. Oops. Put this in quotes. And the address is going to be us. And the amount, I guess we're going to approve it. Each time we're going to approve it for, I can just say, I can just approve it for max each time. Okay, cool. So that is our approved payload. The next thing we want to do is we're going to create this setup here. We'll just call it setup. It's going to be abi.encode with selector. So under here, this is going to be the gnosis dot, did I spell this wrong? Oh, gnosis, what is it called? Gnosis safe? Gnosis safe. Safe dot setup. Dot selector, actually, it's going to be dot selector. And then this is going to be okay. Do I have let me see. I think that should be okay. So I'm just going to put this stuff onto different lines. Owner. Oops. Owner. Oops. Scroll down a little bit here. Clean this up a little bit, make it a little bit more readable here. Okay, so the owners, that's going to be the wallets, right? This is going to be the wallets. What's this warning it's giving me? Undeclared identifier. But I declared it here. Oh, I don't want this here because I'm going to, this whole thing is going to be inside of our loop. So, wallets, the threshold here, I'm just going to put, this is how many wallets you need to, how many people need to confirm the transaction. So I'm just going to put it to 1. The to address is going to be, this is going to be, so it's all like, you can go and kind of read through this if you want to go to the Gnosis safe. It explains all of this stuff, but I'm going to kind of I'll give you the gist of it here. So the address, when it says to here, to, this is going to be the delegate call. Where is a delegate in call? It's going to be a delegate call on this address. The payload here is going to be this approve payload, so it's going to trigger this approve function. The fallback handler here is going to be address. We can put it address 0. We don't need any of this. The payment token, so I'll copy this here. Payment token, we don't need that. The payment is going to be uint 0, and the payment receiver, we don't need that. We can just kind of leave it in a null address here. Okay, so that is our setup. Next, we will create our proxy, which is going to be the Gnosis safe proxy. We'll call it proxy. This will be equal to the factory dot, and then this is the create proxy with callback. This is the function we were looking at earlier here. So basically the singleton is it's just going to be called singleton. The initializer is our setup. We just did, this is the initializer here. This is all the data we're going to pass into the new proxy contract. This is our salt, noach. I don't know. You guys tell me, how do I say this? You know, spell it out phonetically. Noach. This is our salt noach, but this is just basically an arbitrary number, so it can be anything really. I'll just, you know, I can use the block timestamp and that's fine. And then our callback is going to be the registry. Cool. So that, I'm going to just pretty this up a little bit, make it a little bit more easier to read. Okay, so at this point, our attack, so we should have launched a new proxy contract, and then we triggered a delegate call with our setup here that's gonna be our approved payload, and we're gonna be approved to spend the tokens. So last thing we want to do is just, you know, transfer the tokens. We'll transfer it from the proxy to the message sender, and then the amount is going to be that amount. Okay, so that should be it for our attack contract. Cool, looks good. Last thing we need to do is just code up our test. So in here, go to this dot hack, as I like to call it. Await this dot contract factory. We called it backdoor attack. We're gonna make it from the attacker. We'll chain a deploy on here, and then we need to deploy it in the same way. This dot, I think I did, what is it, token, just double check. Oh, I did singleton token factory registry. Okay. What is the singleton? Maybe it's called something different in here. I guess, is it called master copy? Yeah, I guess it's, the singleton is called master copy in here, which makes sense. Call this master copy dot address. This dot token. This dot factory. Wallet factory. Yep. And this dot registry. Wallet registry dot address. Okay, and that should be, oops, That should be good for that. The last thing we need to do is trigger our attack. This hack.attack. And then we pass it the users array, and then we will need to pass it some ethers. This is going to be because each time we loop through, we're going to say, hey, we want to withdraw, because each wallet gets 10 ether deployed to it. So each time the attack is run through, we're going to withdraw 10 ETH each time. Ethers.utils.parse ether, and then we'll just say 10. Okay, so I think that is good. Last thing we want to do is just trigger the attack. Oops, I already did it. Yarn run backdoor. Okay, let's see. Okay, compiling, successful. Okay, oh, and we passed. Okay, so that is it for the backdoor challenge. I hope you learned something about Gnosis, safe wallets, and multi-sigs, and we'll check you on the next one.